Hi everyone, welcome back. Let's begin with exponential function today. Now, exponential function, it's one of the transcendental functions. Now, what is an exponential function? It is usually having the form of y equals a times b of x plus c. So it's unlike the polynomial functions like radical functions and rational functions. You know, the special thing about this is that the variable is going to be placed on the exponent. Now that's, you know, that being said, we have a very weird concepts. I would like to move on to something about, like, you know, the change of y and change of x. Now, if you go on to change of x and change of y, I usually use this tactic also in pre-calculus. Change of x is going to be, it's just going to be positive, but this is going to be multiplication. Interesting, right? Interesting. If I can give you a certain example down here. Y equals 2 to the power of x. Now, if I have y equals 2 to the power of x, and by the way, I wrote this down, y equals 2 to the power of x in the booklet, and you will have a copy of the graph of it. Now, when we sketch the exponential function, the most important thing that you need to remember is that we always start at 0, 1. We always start with the 0, 1, and that's the key point. This line segment, the unit line segment that is, you know, like standing up, is going to be where we begin. Okay. Now, from now on, when we have to transform the function, we're gonna shift this left and right. We're gonna shift it up and down. But this segment is going to be where we begin. Okay. So as I move 1 unit to the right, if I move 1 unit to the right, I'm going to multiply my height, the original height, by twice, because that's 2. I'm going to multiply my height. I'm going to multiply by my height, multiply my height by 2. So it becomes 2. If I go 1 unit further, and I'm going to multiply my original height by 2 as well. And if I go 1 unit to the right once more, I'm going to multiply my original height by just, like, you know, it just keeps going on. So you can see that the graph, it's going to be going up. It's called exponentially growing. But we don't stop here. Maybe we could have actually looked at the previous step, or how the previous step looks like. If you look at -1, we have half of it. Whoa. Because we need to halve it, we need to make it half, because if you multiply that 1/2 of the length twice, then we get the length of 1. And we also get, you know, 1/4. So it gets like shrunk and shrunk and shrunk, but that segment will never ever going to be what? 0. It will never ever going to be 0. So an interesting thing happens. We have the horizontal asymptote. We have the horizontal asymptote. And this is going to be the horizontal asymptote. Okay? So we have the exponential function that goes up. But we can also make sure that we can multiply by y equals, you know, 1/2 to the x. And by the way, there are certain tactics that we need to know, that b, or the certain conditions that we need to always remember, that b is going to be always a real number that is positive. But we distinguish between, like, something that is positive and something that is, like, you know, positive into 2 subcategories. We have something that is smaller than 1, something that is greater than 1. So we might have b greater than 0, but still smaller than 1, or we might have b greater than 1. We might have those 2 possibilities. And if we have something that is, you know, like a fraction, a pure fraction between 0 and 1, we call this decreasing function. The function is going to be decreasing. And you can see that, why that's true if you look at y equals 1/2 to the power x. But this one is obviously increasing, right? This is going to be obviously increasing. Why? Because it's going up. It has the upper going trend. So having said that, that's going to be the exponential function. We would like to look at some basic functions and you know, like how to sketch basic functions, and then move on to some, you know, like analysis of exponential expressions and whatnot. Okay, right. So having said this, I would like to go on to sketching, you know, y equals 2 to the power of x minus 1 plus 1. Right. So we have y equals 2 to the power of x. That's the original function. And we would like to shift this, shift it right by 1, right by 1. And up by 1. All right. Where is the constant segment? Where is the beginning point? The beginning point was 0 and 1, 0 and 1, right? I want you to shift that unit 1 unit to the right and 1 unit up. So we're going to have a picture that looks like this. Okay? Don't, you know, just don't panic here. All you have to do is just to draw the horizontal asymptote. Imagine that's the ground. That's a new ground. That's the horizontal asymptote from now on. Horizontal asymptote is going to be y equals 1. Right. I want you to circle this 2. And that 2 is going to help us how to graph it. If I move 1 unit to the right side, then I'm going to multiply my previous height by this unit down here. It's going to be 2. So I multiply my height. I multiply my height by 2 units. I'm going to multiply my height by 2, and multiply my height by additional 2, and so on. Like this. We're going to multiply my height by half. Multiply my height by 1/2. 1/2. So as you can notice, the graph is going to be really close to the particular graph, really close to y equals 1, and except it goes like spiking up. Goes spiking up, as in the form. Can we analyze this graph? Of course we can analyze this graph. What is the, you know, like a basic analysis of this graph? Analysis of this graph is that number 1, we have a domain. Now, domain is going to be the set of all real numbers. Who cares about the domain for exponential function? It eats everything. It takes in everything, right? But the range is going to be a little bit different, right? The range, as you can notice, is going to be a little bit different. Range is going to be something that is above y equals 1. So something that is above y equals 1. And you can also notice, you can also write this thing as an interval notation. Y is going to be stuck between 1 and infinity. And by the way, domain is going to be the set of all real numbers. If you want to write this thing as the interval notation, hey, that's how you do it. Right? So this is how we sketch the graph of exponential function using the multiplication rule. Remember this thing, right? Remember that we have always the segment, the vertical segment of length 1. We start from there, and as we move to the right side, we always multiply by the unit that you're looking at in the base, so that it becomes that fold times, you know, that it's being multiplied at that number. It's being multiplied by that particular number as we move to the right side. It's a unit movement. As I move 1 unit to the right, it's going to be multiplied by that particular length. If I go to the 2 units to the right, I'm going to multiply 2 squared that unit. And imagine that's 1 and that's 4, right? If I go from 1 to, you know, if I move 3 units, it's going to be 1 and 8. Make sense? Easy as pie, right? So that's question number 1. Not that bad, right? Not that bad. Exponential is not that bad. Of course, we haven't justified, you know, we haven't justified the exact picture or how it is being derived from something else. It is derived from the geometric sum of all the polynomials that you can imagine, but we're not gonna, you know, go on to that level unless we move on to calculus. Now, number 2 is going to be an exponential function that has the same form, y equals 3 to the power of x minus. I want you to sketch a graph in the empty space. I know that you have an empty space down here. Of course, in your booklet, I want you to have x and y axes. And now we're gonna analyze the shape of the graph and see how it works out, right? So we always begin with 0 and 1, right? We always begin with 0 and 1. We always begin with 0 and 1. What do I need to perform? What do I need to perform to that particular line segment, the unit line segment that is vertical? If you see, if you read this question carefully, we have y equals 3 to the power of x minus 2. So what we're going to do is that we're not going to shift it to the left or right by any unit. We're just going to place it downward. We're just going to push it downward by 2 extra units. So if you make it, you know, if you make this, if you push this to the elevator and go down to B2, then we're going to 1 and 2 more units, extra 2 more units, and we have -1 and -2. That's going to be where we begin. And of course, you need to draw the, you need to draw what? You need to draw the horizontal line. Just stating that that is going to be what? That is going to be the horizontal asymptote. And now we have the horizontal asymptote, if any. Yes, we do have horizontal asymptote, y equals -2. And from then on, like what you do is that you start to multiply by the number that you're looking at in the base. As we move 1 unit to the right, we're going to multiply 3 to the original height. Now, if I go up to 3 units, it's going super fast. It's going to be super extra fast. It's going to be extra fast. So it's going to be going beyond this, you know, like the size of the screen. It's just going to go up and up and up like super fast. But as you can notice, this is going to be just like third. This is going to be like exact third. All right? This is going to be third of the original position. Does that make sense? Right. But if I go to the left side, it's going to be 1/3. It's going to be 1/9. It's going to be 1/27. It's going to be extra. It's shrinking extra fast. It's shrinking extra fast. So we get we get the shape of the graph that goes spiking up onto the right side of that the unit vertical segment or edge, but onto the left side, it's just going to be like going super. It's spiking downward, except there's nowhere to go downward. So it's getting closer and closer to the horizontal line, the horizontal asymptote that we have. But anyway, the domain is going to be the set of all real numbers. Who cares about, you know, what you plug in inside the exponential function? That's not a problem. But the range is going to be a little bit problematic because it's got to be greater than the horizontal asymptote. So we're going to write it down. Y is going to be greater than -2. But that's not what you have to do, right? You need to write it down. You need to write the answer down in the interval notation if your school teacher asks you to do so. So we have -2 infinity, and that's it. Easy as pie. So we sketched the graph, and of course the question didn't ask us to sketch the graph, but it's really helpful when we sketch the graph. Whenever I have the exponential function, I always think in terms of a number theory. Like this set of questions will not be coming up unless they are using calculus. They're not going to coming up in competition level math into the super hard types. The only thing that you are expected to see right now at school level work is just going to be exponential function using the quadratic form, but that's it, right? But if you move on to something like AMC 1012 and Amy and above, and some other like equivalent contests, you guys will actually see, and of course for some kids who are studying KMOs, like KMO 중등부, KMO middle schoolers and whatnot, for those of you who were actually studying this, you would have actually seen exponential function and exponential form in number theoretic parts. And the only thing that I can tell you is that the number theoretic part, whenever you have y equals something like a to the power of x and b to the power of, you know, like z and plus something else, and if that's got to be some squared or whatever, like whenever we have this type of form, all you have to do is just like basic substitutions using case works. Using cases, like z equals 0, z equals 1, z equals 2, z equals 3, and you perform extra cases on x. So when z equals 0, x equals 0, 1, 2, 3, 4. When z equals 1, x is going to be 1, 2, 3, 4, and so on. And as you keep doing so, some processes, you guys will actually, you know, get rid of all the solutions using the modular arithmetics and whatnot. But, you know, that's a number theory, and that's also a competition level math. So we don't go onto that. We don't go onto that in Algebra 2. We only sketch, we only learn the basic stuff, right? All right, so we have -2 to the power of 3 minus x. This is ugly. This is not something that is right. So we need to change this. But what do we do, though? You know, like what do we do? Now, the usual transformations that we've learned so far is going to work nicely in this function. So we have y equals -2 times negative x minus 3. There are lots of meaning to this negatives. As you see, this the meaning of this negative, instead of going up, we go down, right? Instead of going up, go down. And instead of going right, go left. Or you might say, oh, sir, I thought that was a reflection about the x-axis. I thought that was a reflection about the axis. I thought that was a reflection about the y-axis. But that's what it is. Instead of going to the right, you need to go left when you perform the usual graph, right? So I'll show you how to do that, right? I'll show you how to do it using the graphs, and you can just see it clearly. Now, we have, we start from where? We start from 0 and 1. We start from these segments. This is the beginning point, right? This is the beginning. This is where we begin. And we're going to shift this 3 units to the right, right? 3 units to the right. 3 units to the right. And this time, even instead of going up, you need to see this carefully though. Instead of going up, you need to go down. You need to go down. Interesting. And what we're going to do is that we're going to go to the left and multiply 2 units. Multiply 2 units. And as you notice, at x equals 0, it's going to be -8. And guess what? It's -8. But as I go to the right, I'm actually halving. Imagine the world that has been turned upside down. It's going up. Sir, I don't get this. I'll make sure you get this, right? Usually when we have y equals 2 to the power of x, we had change of x and change of y into the positive direction. Into the positive direction. Yes? This time, what we're going to do is that when we have y equals -2 to the power of -2x, I would like to have -1 and -2. So -1 means that I'm going down, I'm going to the left side, and multiplying by -2 is just going to be, go downward. Just keeps going downward. It's not something that, it's not something that we've always multiplied by -2. Doesn't mean that. It's just going to be, like multiplying by 2 and -1. Okay? So that's how it works. And we need to state the domain. What is the domain? Domain is the set of all real numbers. So do you think that your school teacher will ask you about the domain in exponentials? No. Your school teacher will not ask about this because it is obvious. Anyone can guess the answer. So she or he wouldn't ask this question, but I'm pretty sure that your school teacher will ask about the range, right? How would they do it? Well, it's just going to be y is going to be smaller than 0. Sir, I don't get it. No, you do know. You get this. Check this out. Oh. You see, that particular line that you're looking at is going to be the horizontal asymptote. And horizontal asymptote is going to be y equals 0. And we have y equals 0 as the horizontal asymptote. And as we have the y equals 0, it's always going to be smaller than the horizontal asymptote. It's going to be approaching that line, but it's not going to touch, especially in our cases. Yes, so it won't. So that being said, I think we're ready to move on to the next question as well. Okay, exponential equation. Exponential equation, only for school. For school. So since we haven't learned about logarithm, and logarithm is going to help us expand our working mechanism to solve lots of exponential equations. And at your school, you guys will see this multiple times. But from now, in this case, what we would like to do is just to equalize the base as much as possible. So number one rule is to equalize the base. Without further ado, you need to equalize the bases. Now, how would you equalize the base? What does it mean by equalizing the base? Well, it means that we need to equalize the base in terms of prime factorizations. In prime factorized form. In prime factorized form. So suppose I have something like, like 16 to the power of x, I'll give you an example, equals, let's say 8 to the power of 2. Let's imagine we have these expressions, okay? 16 and 8, they are equivalent, yes. 16 is a multiple of 8, but in core, deep down, like in deep down structure of this whole, expression, we know that 16 is a power expression of 2, and 8 is also a power expression of 2. Whoa, so maybe that can be written as 2 to the power of 4x and 2 to the power of 3 and x. Whoa, 2 to the power of 3 and 2, right? So does that mean that we have 2 to the power of 4x equals 2 to the power of 6? Yes. As long as we equalize the base, we're happy to move on. 4x is going to be 6. Right? Easy as pie. But if, well, what about the other stuff? Like, is there a way to equalize the exponents? Sometimes it might help. Sometimes it might help. Sometimes we may have to equalize the exponent. Yes. Equalizing the exponent. The exponent. But equalizing the exponent only comes out in competition level math, especially when we are comparing large numbers. When we have to compare large numbers, we do have such. I'll show you an example. I didn't write this thing down in the booklet, but why not? What if you have something about, like 5 to the power of 8? And I want to compare this 2 to the power of, let's suppose 10. I want to compare these numbers. Going to compare these numbers. And how do we compare these numbers? Like which one is bigger? I don't know. Like 5 to the power of 8 is going to be bigger. But, unless we use the calculator, what we do is that we need to make sure that the top part, if we just simply look at equal bases, as long as we make the equal basis, we know how to compute a smaller number. 5 to the power of 4 equals 625, and this one is just 32. Obviously, it's going to be, like the left one is going to be obviously greater than the right one. So this is how we use, and this is more like AMC 8, right? I'm sorry, this is AMC 8. This is more like AMC 8 materials and like a middle schoolers. But when you have to compare the, like numbers, man, you need to compare the exponents. And the last set of things that you need to know is a quadratic plus exponential. But that being said, we're not going to move on to the sets of questions. I would actually go on to the question next time, right? So I want you to review how we graph the exponential function. The way to graph exponential function was using that particular vertical segment, right? The vertical edge of length 1, and we keep multiplying, certain base unit or the numbers that appear in the base. And as we multiply by base, we keep increasing my height. And if I go to the right side, then that's going to be a little bit different. We need to divide it by, we need to divide that particular height, the segment 1, by the base in order to come up with the proper function or the proper graph. So that being said, I'll stop here. I shall see you next time. Thank you.